Okay, welcome to Western Tradition Learning Center. So today I just wanted to discuss modern atomic theory, meaning theories about what the atom looks like, okay, and how it's changed over time. So the first one here on the left, at the top left there, is Dalton's model. And Dalton's model stated that the atom was just like a billiard ball, just a ball, okay, and you couldn't crack it open, and matter was made up of these atoms. We know that that's true and not true. It's true that yes, matter is made up of atoms, but there are smaller particles called electrons, neutrons, protons. So the atom is not the smallest. It's not the smallest part of matter. All right, so Dalton was correct, but yet not correct. I mean, no one can be perfect, and of course, very hard for him to come up with this in 1803. But we call that the billiard ball theory or Dalton's theory. Now, Thomson did those experiments with the cathode rays, and he came up with this idea that there were things called electrons, which there are. And he said that they were kind of stuck in the atom, almost like marshmallows in chocolate pudding, or raisins in bread, and they were negative, the electrons, and then the bread. Say the raisins were the electrons, and then the bread was positive. That's what he said. Okay, which is very, very interesting. And he was correct in the sense that yes, there were things called electrons. Now Rutherford came up with this idea, that there was a hard center from the gold foil experiment, which we call a nucleus, and that the electrons went around this nucleus, which is true. Okay, it is true, which is very interesting. Now the next thing is the Bohr model, and that's very interesting because that states that yes, there is a thing called a nucleus. In that nucleus, we have neutrons and protons, and that around the nucleus are these things called electrons, which are in these pathways, which they call orbitals. Okay, which is fascinating, and that's the one really I think most people have in their minds because it's kind of the easiest one to grasp, at least for me. An orbital is described as a region in which an electron of a particular amount of energy is most likely to be located. So the orbitals, as you can see them, those you see 2 in the first orbital and then 3 in the next. I'm looking at the Bohr model, 1913. The idea is that the orbitals, hold the electrons in place, so to speak, and they don't go off that pathway, almost like the moon, around the Earth. Or a moon around a planet. It doesn't, the moon doesn't deviate from its orbit around, whatever planet. That's the idea. And it's a good one to have in your mind. I think that's the one that you should really get in your mind. Just for simplicity's sake. Think of this hard center. And the reason why that model there has different colors is because, because the nucleus is made up of, protons and electrons. And then outside of that are these, orbitals, and in those orbitals are these things called electrons. Then on the right-hand side, we have now the electron cloud model, which is really the present one. And that's really very popular as well. There's a difference, though. There's a difference. The difference is that the orbitals, the electrons are not in some sort of orbital that kind of keeps them in place. It's like the electrons can move within those orbitals, kind of shimmy back and forth, so to speak. Let me read to you something about this. Let me see here. The wave mechanical model. The wave mechanical model. This modern model of the atom, right, pictures the atom as having a dense, positively charged nucleus, as proposed in the planetary model, which is the Bohr model, okay? The major difference between the wave mechanical model and the Bohr model is found in the manner in which the electrons are pictured. So that's the difference between the Bohr model and the electron cloud model, which is the wave mechanical model. Instead of moving in definite fixed orbits around the nucleus, as suggested in the Bohr model, the wave mechanical model portrays electrons with distinct amounts of energy moving in areas called orbitals. An orbital is described as a region in which an electron of a particular amount of energy is most likely to be located. Okay, so thus the modern model of the atom is not the invention of a single scientist, but rather one that has evolved over a long period of time. It's just the idea that there are no hard and fast orbitals. This is what they say, but like the orbital is just a region where they most likely are. So it's almost like they're there, but they're not like on some sort of like conveyor belt, you know, going around and around. I see it in my mind as the idea that they can move, not necessarily out of it, but they stay in a given region. They stay in a given region. It's almost like, you know, you walking down the street, but you can walk, you know, from side to side on the street. You don't have to stay in a straight path. That's the way I look at it. So those are the differences. I hope this video was helpful in some way. You know, for your purposes, if you're taking this in high school, which I'm sure you are, just know the differences between these models, okay? The Bohr is really the most popular, you know, the planetary model. That's the one that's my favorite one. It's kind of because it's easier to understand. You know, the electron cloud model is just saying that those orbitals are not necessarily hard and fast. So, anyway, I hope you enjoyed that. Take care. Bye-bye.